So the first question we had for you guys, what were some issues that you guys encountered with the design process during COVID?
I guess one of the biggest ones is since we're operating in a garage now, our floor isn't like completely even, so just bumps in the floor make it actually very difficult to make some maneuvers possible. So we had to spend a lot of time making sure autonomous didn't run into those kinds of issues.
Yeah, and to deal with those type of things, like we made a lot of these like kind of hinged, which means like it can go up and down based on like where it's.
Very compliant.
Yeah, that must have been something new to have to like adapt to your environment that your robot's going to be in, because normally you wouldn't have to do that.
Yeah, definitely.
Yeah. Ink and Metal, if you guys want to answer that question.
So with the design process, we kind of, in previous seasons, we didn't leverage CAD as much. But this year we leveraged CAD as a software tool much more, as people who necessarily couldn't come in person were able to contribute through online CAD meetings. So here is our robot, if you can see that. Lighting may not be the best. But design process wise, not initially due to COVID, but something we had quite a bit of trouble with maybe is our outtake, I guess, because we started off with a really inconsistent outtake back in November or so, and with a single motor. Then we decided to go with a dual motor outtake around February, and then we built that, and that was pretty good. And then we changed it up a bit here and there. We changed our Go Builder motors to the modern robotics motors. And it was kind of weird 2 weeks ago, much better now, and there's still room for improvement. Up here, there are brass flywheel weights at the top to add mass to our flywheel. That way, between each ring as it's shooting, it's able to reach its target velocity faster. So our outtake was probably arguably the hardest part of our robot. We even had a lot of 3D printing issues with it. But yeah, we've definitely been able to use CAD a lot more this year.
And then I guess another question that we had was, what were some mechanisms of your robot that were the hardest to build?
I don't know if you can see, this is the front. It's changed slightly since that one video, but not much. You can see we have a compliant wheel, hinged compliant wheel, initial set of wheels. And then we have, I think, the part that's changed the most is after that. Here we have a series of rollers that we initially didn't have. We started off by relying on the initial velocity of the rings to make it up the ramp and into the lift. But we found that was terribly inconsistent, and we had to like retry it and to get it up like way too many times. So yeah, we spent a lot of time tweaking it to make sure it got up like each time actually.
I think when our first iteration we faced like a similar issue, which is why we like switched to belts. But I mean, yours works pretty well. So also I like the front shield thing you have. It seemed to help a lot during the matches.
Yeah, it was mainly intended for the starter stack to make sure we didn't try to intake more than one ring at a time. But we also like modified it so I can tilt outwards and help with like making sure rings rolling towards us fall down a bit faster. So it was not really
interesting.
Yeah, I've never seen that before. That's really cool.
And then obviously you guys have had a lot of iterations. So how do you guys make sure that you have like time for iterations, and how do you make sure that your efficiency is, you're being productive and you're efficient in order to create time for those iterations?
I'd say the main way we do that is just by thinking it through and trying to identify all the major steps that would be needed to make it possible. And I don't know, over these couple of years that we've been doing this, we've developed a bit of intuition as to what is actually possible in a given time frame. So just using that, we try to make the best decision possible.
Yeah, and then I think for us, that would probably be implementing our design process. So we have a variety of stages where we generate concepts, develop solutions, and then we actually prototype it. And Yeah, and then also like our heavy documentation on those tasks in online meetings, that would probably help with efficiently bringing an idea into a physical iteration of a robot. And then we also want to ask about the autonomous paths. So how were you guys able to determine the path for a robot in autonomous and teleop strategies to maximize the efficiency and points in each match?
I think we just did a few iterations of trial and error, but I don't know. We just kind of found the optimal shooting point for our robot and kind of went around that. And then we just tried to make sure we weren't doing too many unnecessary movements.
Yeah.
That's basically how we engineered it.
Mhm. Yeah, definitely. For us, we're using odometers this year, so we use the software Roadrunner, and with that, we were able to use line to linear headings, different types of movements. So we mostly kept it to lines because that would obviously be the most efficient. And yeah, earlier, or actually like last year, in December, I think, we were using the our path visualizer, which is also by Roadrunner, to plan out paths so that we didn't actually need a robot. It was more for like the virtual robot. So we used that to create different iterations of autonomous paths for each of the members as well.
Yeah, we do a similar process actually. I didn't mention it, but we have a custom path following and path planning algorithm that we've implemented. And yeah, we can just specify a few like heading waypoints and rotation waypoints, and it'll interpolate between them and follow it as best as it can. We don't use Roadrunner, but we use the FTC dashboards. That was also part of that project. So we use that to visualize it, and I think we're also working on a Java application that would be used to virtually like plan them out beforehand as well. So yeah, that's how we do it. We also use odometry. I think we use 2 dead wheel encoders and the IMU.
Yeah.
And then, did you guys have any driver enhancements that you wanted to highlight or share?
Yeah, actually, most of our shooting is now automated using that odometry system. So at any point, it'll aim to make sure it makes its shots. We can set its target aiming point to either one of the the high goal or one of the 3 power shots. And it even has like an automated power shot routine, which it does on its own. I think, yeah, we also, to make that a bit more accurate, we use the camera here to reset its odometry pose using Vuforia every once in a while, so we don't actually accumulate too much drift.
Rahul, if you'd like to answer the same question about driver enhancements.
A couple of the driver enhancements we have. I'll give the computer that I use, but I can continue speaking. Using odometers, we automatically return to the shooting position through the Roadrunner pathway. So that really makes it easy for our driver. He doesn't have to, manually align, because that can result in a lot of human error. So that we use odometers to return to the shooting position. Now we're turning on our robot, and we have LEDs all around the robot. And sometimes our driver have difficulty with telling if there's, in our transfer, if there's 0, 1, or 3, 0, 1, or 3 rings in there. So when there's 0 rings in there, we have the LEDs be red. When there's 1 ring in there or 2 rings in there, they're yellow. And then when there are 3 rings, they turn green. And the way we figure out if it's 0, 1, or 3 is we have a distance sensor right underneath the transfer. And it detects, of course, the higher this is, the smaller the distance sensor reading is.
So yeah, like I was saying before, we want to also talk about the other side of FTC, which is contacting with mentors, making connections with others, and budgeting for your team. So this year, have you guys gotten into contact with any mentors or made any new connections through your outreach? And if so, how were you able to do that?
Yeah, I think one of our contacts is a startup called Printer Press. They're in like the biomedical 3D printing industry. So yeah, we did contact them and we got a sponsorship from them, and they also were our fellow mentors for a little while. As in, like, we got a tour of their facilities. We got to see all the different like technologies they utilize on a daily basis. And they also, since they're engineers in the field, they gave us a bit of advice on optimizing the structural integrity of some of our 3D printed parts, or just our robot in general.
Yeah, that sounds amazing. Yeah, so a few of the mentors that we have is the Stanford Student Robotics team and the Princeton Robotics Club, who gave us advice for choosing our 3D printer. And they also helped us design a few mechanical components. And one of our most helpful mentors is actually a first alumni who was from our team a few years ago. And his name's Francis Ung, and he regularly joins meetings. And since he has a lot of experience with the team and with FIRST and FTC, he helps us out with designing the most efficient components. And if we have any trouble, we can always just go to him.
Cool.
Yeah.
Yeah. Since we're like a community team, that's just a bunch of friends. A lot of stuff we do is mostly self-taught, and we've kind of learned how to do a lot of things ourselves.
Mm-hmm.
But yeah.